Welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist with the University of Florida. And this is our podcast, where we dive into the main topics affecting livestock and forage production in the southeastern United States. Join us in this journey as we tackle the main issues affecting our producers and the sustainability of our production systems. Welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist and Associate Program Leader with the University of Florida, and this is our research in perspective, the series of episodes that is bringing to you the latest in research that we're developing here at the university. Today, my guest is Renan Pedro Becker, master student with the Forage team and soon to finish his degree here at the University of Florida. Renan has done a lot of work with bahiagrass, and we're here to talk a little bit about bahiagrass seed production, which is one of the first papers that's coming out of the work that he developed, hopefully soon to be published in one of our main journals. Renan, welcome.
Thank you, Marcelo. Hi to everyone that's listening to our podcast. It's a pleasure to be here.
Thank you so much. So bahiagrass seed production, it's a very important industry here in the southeastern United States. What was your interest? What drove you to look into seed production in bahiagrass as part of your work you developed here?
Yeah, so I think one of the most things that popped up into my mind when we were coming through that is that whenever we think on those species, they have several advantages, mostly about being perennials and persistent and all of that. But when we come to the point of having superior lines from the ones that we are using till nowadays, how is the process of creating this material and delivering that to the field that they can have a broader scale and can reach to more places, to more area? And when we think in wheat, ryegrass, oat, and all of this, it's pretty simple. You get the seed and you plant it. And for bahiagrass, you have the same, but there are several other challenges that happen in the terms of seed production. I got excited to study a little bit more about that and understand which are the procedures that happen behind that and try to understand a little bit more of this.
So just to bring a little more context to our audience, University of Florida Forage and Forage Breeding team has in the past several years developed multiple tetraploid bahiagrass materials that now we're evaluating for seed production. Many traits prior to release, including seed production. Let's begin with this. So what is a tetraploid bahiagrass? What are we talking about when we say tetraploid? And aren't there a lot of cultivars of bahiagrass in the market already? Why do we need more here?
Exactly. That's a very interesting question. And bahiagrass could be subdivided in two main groups, diploids and tetraploids. The main characteristic and difference of that is that the diploids, they reproduce sexually, so two crosses. It's very much easier to make crosses and to select breeding program advance and select new lines, new varieties that are more productive in the diploids. For the tetraploid, they have a different mode of reproduction, and at the end of the day, they will produce a seed that is exactly a clone. So it's more difficult to breed and select for superior entries from that. And that where it comes into play that we only have one cultivar available from tetraploid that is here since early 40s. So almost 80 years, I can say. That's Argentine and is still used nowadays and still have a very good persistence and productivity. This is why we have a lot more options from diploid bahiagrass in the market.
That's a very good explanation to understand a little bit of that market dynamics. And it's my understanding that our farmers, a lot of them really like the Argentine, the tetraploid types bahiagrass. Why is that? Why is this perception?
Tetraploid, they have the double genetic content than the diploid, and it can also be expressed on the plant appearance, how they look. They can have broader leaves. Mostly Argentine, they grow more horizontally over the soil, so it covers the soil. It's very persistent as well. And also because the morphology of that, the broader leaves, there is an impression that cattle prefers this type of bahiagrass. And also that's used since the 40s, so it's still used nowadays compared to others. So people really like those, but they don't have a lot of options from other in the market because those issues with to breed and to select for new entries.
So one of the main characteristics of the tetraploids is that they tend to have less seed heads than the diploids, and that's a great thing, right?
Yes, that's a great thing when we think about forages. Although when we think about seed production, that's not a great thing. Why? Because to produce more seed, and if we come back from seed until the plant, what has to happen for a plant to produce seed? That individual plant has to produce a seed head, an inflorescence. That inflorescence, if you see closely to that, it has several florets that will become a seed later. So each one of those florets has to produce a seed. If you have less plants that produce seed heads, so less seed heads as in tetraploids, you will get at the end of the day less seed production. And if you have less seed production, okay, that's an issue if you are a seed producer. But thinking on the maturity of the forage, that's very interesting because that material that actually goes to seed, it's mostly a stem and that has low nutritive value compared to leaves. So it's very interesting to have that as a forage if you have it already established. But if you want to renew a field and collect seeds from one field that you have and plant in another one, that's an issue because you will have the less production compared to Pensacola and other types.
And that's how seed prices go up. They would drive the seed prices. So we talked about several new cultivars being evaluated now for cultivar release in tetraploid bahiagrass. What was the rationale behind your trial in terms of seed evaluation? What aspect were you looking in terms of how to produce more and better seeds from those tetraploid bahiagrasses?
So I first started to see what was already done with bahiagrass to check what worked and what didn't work. Early in the 1940s as well, when bahiagrass was still establishing because it came here in the US in 1913, 1914. Van Burton at the University of Georgia, he did some studies working with several grasses, and mostly what he found was that clipping or cutting it removed that old biomass that was accumulating over the winter, the new growing season, and fertilizing that mostly with nitrogen was the most effective practice to produce seed. That still continues nowadays, but later on we saw that there are more factors that are involved and we should pay attention to the time that we remove the biomass, how much of it, and how much of nitrogen we apply. So we had several works done on that, and then I start putting it together and seeing how much each one influenced another and what we could do after to improve it even more.
So let's decompose this a little bit. You're talking about the removal of biomass and the timing of removal. So what is happening here when we do this? And most of our farmers are either going to graze it heavy early in the summer or mow it very short. What are we getting when we do that management?
So what we get out of it is that we have more probability to produce seed heads. And the seed yield is built by three factors: how much inflorescence seed heads you have in your field, how much seeds each one of these seed head will produce, and if they will be filled or not at the end of the season. Those three components. Numbers 2 and 3, they are mostly driven by genetics, so we cannot change it a little much. And number 1, seed heads per area, we can. Mostly is more influenced by the management.
So basically we're saying that whenever we mow it short or graze it short, we can increase the number of tillers that is going to lead into the increasing number of seed heads.
Exactly. It's exactly like that. And all the other factors, they come to a play that why to remove that old biomass? Couldn't we just leave that and wait till it produces? Actually, no. But we have, in other words, to stress a little bit the plant and stimulate that to produce a new biomass. And why does that happen? So there's not a clear link between how much of forage that the pasture will produce and the seed head. And there is a huge factor of influence of sunlight also on stimulating the production of the new tillers and new seed heads on that. So for bahiagrass to produce this greater amount of tillers, we have, in other words, to make the sunlight reach the most bottom of the canopy. And why do we have to reach that if the leaves are capturing that sunlight at the top? That's because the leaves, the top of the leaves, doesn't have the ability to produce new tillers. And where is a tissue, the part of the plant that has this capacity? Is at the bottom of the canopy, close to the soil surface, and it's actually the rhizome. It could be seen as a thick root, but it's actually a stem. It's not a root, and it's right below the soil surface where it has the capacity to produce a new shoot, a new leaf, a new plant. And so if we are able to open that canopy and make the sunlight reach that part, that tissue of the bahiagrass has the capacity to produce new tillers that later on can come to a new seed head and produce more seed.
So perfect. So we went from decomposing this seed production part. We go from We need to open the canopy, get more tillers, then those tillers are going to become reproductive. And then that drives number of seed heads, and hopefully we can get more seeds from that.
Exactly. That was exactly the point over my master's of one part of this, besides the other traits we were evaluating of those new entries. And we came with the idea of see if not only cutting, but cutting it to different heights could have an influence. Then we hypothesized, okay, this might be the best timing to cut to late spring. Let's cut the plants to 5 and 10 centimeters, 2 and 4 inches, and see what happened, in other words. And that's what we did. And truly speaking, when it was harvesting time, I was not expecting a huge difference on that because everything kind of looked the same. You couldn't see that much in difference in biomass. But we start seeing that whenever we cut to 5 centimeter, even the other was cut, we had more tillers and we had more seed heads. And for some genotypes, then we had more seed production, and for others, don't. But we achieved that greater seed production capacity, although some of those were not able to reach that, which was very interesting and still bring a lot of questions to us of why that happens and how.
So basically, some of the genotypes were not able to realize that capacity of increased productivity, even though they had more tillers, did not result in greater seed production. Was there any effect of that in terms of seed quality or seed weight and then seed quality?
So the most productive entries, they generally had the lighter seeds. And that could be probably because if you have less seeds to fill, you will fill them the same way as the others. But as more seeds you produce, you will not allocate that much of energy to each one of that, and it can be that. And other aspects of seed quality, we didn't do germination tests, but we assessed that in another way. That is a test that was done in a lab that's called tetrazonium cell test that tells us how much seeds are viable. And then we could not see huge differences among the lines that we evaluated. So it looks like as further we go from the production of tillers to seed heads, seed production, then to the quality aspects, those management applications, they kind of have less impact than those later ones, the quality traits, and it's more driven by genetics.
So considering that Argentine is our industry standard, our baseline, from the interest you're evaluating, was there any improvement compared to Argentine in terms of seed production?
Yes, there were improvements. Some of them produce 2 or 3 times as much, but then when we start seeing as the purpose of releasing those new lines, those lines were not the most productive in terms of forage production, or either the not persistent ones. So, which is the main goal of the breeding program of delivering a new forage, is see if it performs good as a forage. And this was a side assessment to check if those entries had the capacity to produce and to maintain levels that can stand a cultivar in the market. And unfortunately, those that produce more than Argentine were not the best one in forages. That's the main purpose of the project.
For sure. And we're testing those other varieties. All those materials we're testing under grazing also to see which ones are going to produce best and persist best, not only on seed, but also in terms of forage production, and to make a wise decision on what fits best the market. Of course, we want seed, but we need to persist. We need more productivity. So it's a compromise. But I'm excited to see that we're at least as good as Argentine for most of those traits on the top performing lines. And we'll talk more about those top performing lines in another episode when we discuss the grazing trial. I want to wrap up with a quick message here. Based on your experience that you had so far, if you are to recommend farmers in terms of the cutting heights for improving seed production or seed potential seed production in nitrogen management and timing, what were the parameters you would give?
So it doesn't change that much from earlier works that have shown us that we have to defoliate in mid to late spring.
Okay.
But yes, we see that it's not only cutting, but how much we are cutting, it has an influence. We are testing here 2 to 4 inches height, and cutting to 2, we increase the potential. Some of them reach, some others no. I think if further studies could assess if even maybe clipping more, or maybe other methods of disturbance could also influence on that. Maybe lightly disking it over the soil could have an influence or not. This is just guesses, something that we could test later. But taking out, removing that biomass in mid to late spring and fertilizing it with intermediate levels of nitrogen fertilization around 100 pounds per acre. That could be one of the most efficient practices to increase bahiagrass seed production.
Fantastic. Renan, appreciate you coming today. For those that are interested in more on seed production and research, take a look into some of the documents we have published in the Florida Cattleman Journal and also in the Pinhandle Ag News, where we're going to publish soon an article about bahiagrass seed production. Reach out to us through forages@ifas.ufl.edu if you have any comments. Let us know what you thought about this episode. Thanks for participating, and I'm looking forward to seeing you in the next Our Research in Perspective.
Thank you so much, Marcelo. It was really nice to be here.
This podcast was brought to you by the University of Florida Forage Team with technical support from the University of Florida College of Agriculture and Life Sciences, Faculty Instructional Resource and Support Team. This episode was produced by Marcelo Wallau, Olivia Mowley, and Ashley Kanabrowski. We hope you have enjoyed this podcast. If you have any comments or thoughts to share with us, please reach out to us through our email, forages@ifas.ufl.edu, and find us on our social media, uf.forages on Instagram, UF Forage Team on Facebook, or UF IFAS Forages on YouTube. We hope to see you in our next episode.